And this is the last case of solving system of equations by substitution. The first one was when both equations are set up in a slope-intercept form, or should I say y equals something and y equals something. The second case was when one of them was set up as a y equal, and the other one was in standard form. And the last case is when both equations are in standard form, so we really want to change one into either slope, intercept form, or just y equals something or x equals something. And I think in looking at the first equation, this one has 3x and 2y. They're not really ready, but I love the second one. When I look at the second one, I'm looking at x. All I need is to have x equals something. So let me change the second one into x equals something. So I'm going to do that by, let me copy this first. As usual, I'm going to solve equation by doing inverse. And I'm going to take inverse. We have 3y on the left and 3y on the right. When I do that, this is what happens. X is negative 3y, take away 5. All right, so our second equation changed the form. So let me copy this again so we know. So first equation, we didn't do anything. But the second equation changed the form. Now it looks like x equal negative 3y, negative 5. So these are two different looking equations, but they're still the same thing. And now, looking at this, I can see why I can do substitution. I can look at a second equation and I say, x is this value. In a sense, I'm going to replace x in a first equation by this. So here's the first equation. It's going to be 3x, which is going to be all of the second equation. And I'm putting parentheses because I need to remember that 3 times x is technically 3 times all of this. That's why we have this multiplication here. And the rest I'm just going to copy because we cannot lose that information. And great. Out of 2 equations, now we are down to 1 and we know how to solve multi-step equation. Let's do PEMDAS. Just parentheses first. 3 times negative 3y. 3 times negative 5, negative 2y equals 7. Oh, I see. I can do combine like terms. Negative 9y and negative 2y. That's negative 11y. Negative 15 is equal to 7. So this looks promising because now here I lost parentheses. And then I combine like terms, so I'm down to 3 terms. And I can keep this line going to keep left and right in order. And I can do my inverse. Instead of negative 15, I'm going to add 15 to simplify it. So this is going to turn into 0. And 7 plus 15, that's a 22. So let me see what we have now. Negative 11y equals 22. All right, well, I know the last thing I need to do is do the inverse of multiplication, which will be division by negative 11. Negative 11. And I can see that 22 divided by negative 11 is negative 2. So I'm really happy here because y is negative 2. I have value of y, and I'm ready to figure out what x is and how perfect this is. All I have to do is go back up here. It's like, oh, well, x is all of this value. And since I know that y is actually negative 2, let me replace it, negative 2. So what I have now is negative 3 times negative 2 is 6. Take away 5. Okay, so I have x number 1. So final solution for these 2 equations is x and y, which happens to be 1 and negative 2. So at this point, are these 2 equations equal? And that's considered system of equation solution.